Okay, guys, now that we've seen how to put together a very simple OpenGL application.
A rotating cube.
A rotating cube, which had very simple colors on each of the faces.
Right.
Now it's time to move into the world of textures. Everybody knows what a texture is. Nowadays, you can't look at any 3D application without looking at textures. It's a way for us to go in and generate a significant level of detail without adding lots and lots of geometry.
Right.
And it's really just a smart way to work. So, in our case, you know, shading our cube with single colors is kind of cool. Not really. We really do need to pick up an understanding of textures and how to work with them.
Right, so we can apply various colors, like multi-texture colors.
Like if we want to do a brick texture or
right,
a
or a marble texture.
Ooh, marble. Yeah, things like that. So what we're going to do over the next couple of videos are first introduce you guys to kind of the workflow / pipeline of dealing with textures.
Right.
And we're going to talk about how textures integrate with OpenGL to end up in your 3D virtual world in this video. And in the next video, we're going to show you guys how to load in your most simplistic TGA file.
Right.
And to work with it, get it set up, and we're going to put that particular target file on the faces of our cube.
Exactly.
So that you guys can see the entire process through code of bringing in your own textures and applying them to your own
Right,
geometry.
even though it's a really simple example, once you understand the workflow you need to get a texture applied to a particular polygon, it's very easy to go and extend that.
Oh, yeah, for sure. Okay, let's go ahead and step into the first slide that's going to talk about the types of textures. Yes, that's right. There's 3 types. Surprise, surprise. A lot of you guys may be going, wow, 1D textures? Yes, there is such a thing as 1D textures.
Yeah, you can have things like gradients where it just goes
from one
from
color that's just shifting
to another color or something
Precisely.
like that.
Now, 2D textures is something that
everybody knows.
Everybody knows. Come on, think of Photoshop, Paint Shop Pro, etc. You go in there.
Think of any of your popular games.
Well, think of anything that you see on your monitor, right? You slap down some color, you make a pretty picture, and what do? You save it out as a bitmap, a JPEG, a TIFF, Targa, a GIF. It goes on and on and on. So many different formats these days. And 2D textures is what we are going to be most interested in because it's what you're going to find most commonly used in real-time graphical applications. That's right. And then, of course, we have 3D textures.
Right. 3D textures basically allow us to do things like...
Oh, let me do this.
Yeah, okay.
All right. Everybody, close your eyes. All right. Right now, you're seeing darkness. This is your virtual world. Now, every single point in this virtual world can have a different color. Okay, so all these colors, they're static colors. They're not changing, but they all have a different color, and we can assign these colors, right? Now we take a piece of geometry, and we put it in the virtual world.
Right.
And you can see that the geometry now has all of this different color that's going to represent a texture, right? But here's the interesting thing. If we chop this geometry in half and pull the pieces apart, you can see how the texture actually flows down through where we just cut it in half.
Exactly.
And some good examples would be like marble. If you took a large marble stone in the real world and just thunk, chopped it in half.
Right.
Or wood. Wood works great because if you cut it in half, you get those rings that work their way inwards.
Right.
Same exact thing. And we have the ability to generate them.
Right. The downside, of course, with 2D textures, very simple to create. Go into Photoshop, slap on some colors, and booyah, there's your 2D texture.
Right.
3D textures, not so simple. Typically, you have to create a function that basically you're given an X, Y, and Z location, and you have to generate a particular color for that location. And that's complicated. A programmer has to go in and actually do this.
You've got to be able to visualize your texture now in a whole new kind of way.
Right.
As opposed to the way you're used to visualizing it in Photoshop, etc.
And it's time intensive, too.
Oh, for sure.
Right.
So, that is just a quick look at 3 types of textures that we have to work with.
Right.
Now let's talk about, go ahead, ST coordinates. Applying our texture, again, right now what we're going to do is start focusing on 2D texture.
Exactly.
So 2D texture is like picture a piece of wallpaper or pick up a piece of paper that's got something written on it and picture that as a texture.
Right.
Now we want to take, I'm holding a piece of paper right now, so Joel is getting one heck of an example. So say we want to take this texture, this piece of paper, if you will, and we want to apply it to a 3D object.
Right.
So if you look around your room right now, or just look at your monitor, how are you going to take, if this piece of paper represented the texture you were going to apply to your monitor, how are you going to take it and fold it all around the monitor in order to cover it properly so that it looks textured, right? It really is. An example Joel used earlier when we were just talking about this is wallpaper.
Right.
And it really is like wallpaper.
Very much like it.
And, you know, as it works in OpenGL the same way it does in the real world. You can screw your wallpaper up real quick
very easily
if you're not paying attention and being careful.
Right. I mean, think about the difficulty you would have if you tried to wrap wallpaper around a spherical object. It would all clump up in one end.
You've got it, all the bunching and all, or even just applying it to a flat surface. If you're not paying attention,
right,
you could have it all bunched together. Then you could stretch it out,
and
possibly
skew it everywhere.
Exactly. Trust me, I've done things like that before. It's no fun. And you can do these things in OpenGL as well. Now, there is a coordinate system, a new coordinate system that you guys are going to be introduced to, and it is known as the ST coordinate system.
Right.
For those of you that are familiar with 3D applications like Maya or Max or XSI, I am quite sure you're familiar with UV coordinates.
Right.
It's the same concept. It's the same thing. Okay, it's basically
it's just different terminology.
It really is. I mean, it's kind of the same as the XY Cartesian coordinate system in 2D space.
Exactly.
And it maps out the same. As you can see, Joel has got this really cool picture up there, and you can see that we've got 0, 0 at the bottom, and then we're working our way over to 1, 0. As a matter of fact, let's go ahead and jump over real quick, Joel, to a whiteboard, and I'll give them a real sloppy drawing. How about that?
Nice.
So everybody loves my sloppy drawings because I sit over at a funny angle from the monitor.
We do.
So here we go.
This is a square, people.
All right, Joel is already ripping on me. Yes, this is a square. No, what this is a surface.
Right. Think of this as a simple polygon.
This is a polygon from our model. So in a few minutes, I'll draw it out in more of a 3D form.
We're looking dead on at our 3D cube.
We're looking at the front of it. That's right. So S divisions, or our S coordinate, is going to run from left to right.
Right.
And our T is going to run vertically from bottom to top.
Right, and you can easily think of this as simply X and Y.
It really is. In fact, I'll just go ahead and throw that in because that's going to help make things a little bit easier to see in regards to putting your numbers in.
Although this is kind of a new concept probably for a lot of people, don't over-confuse this with yourself.
You're already there.
You're already there.
Yeah. If you get confused at all, you're really blowing it out of proportion. So here's how this lays out. So basically, we start out with 0, 0. Well, when you represent X, Y coordinates, you always represent X first, right? Same thing here. This is going to be our S, and this is going to be our T.
Yep.
So as we go from left to right over here, what do we end up at? Well, our value goes from 0 to 1.
Yep.
So we end up with 1, 0, like such. Now, as we go, we'll pick on this side over here. So as we go vertical, now we go from 0, 0 to, 0, because we have not moved off this far left-hand side, if you will, 1, because we're now maxed out in T. Which means, obviously, as we move all the way over here, the upper right-hand corner, we're at 1, 1.
Right, and remember, this entire texture, whatever it is, maybe it's a 256 by 256 texture, is mapped to a 0, 1 area. So no matter how large or small your texture is,
it's going to, with these coordinates, it's going to fit right in there.
Exactly.
And that's the key. I have just established coordinates for this polygon.
Right.
Not only have I just drawn them out for you guys to get an idea of what range we're looking at, I've really specified them. So let's go ahead and pretend I've made some really cool texture. So here's my texture. Let's see. I know.
A sun.
Close.
A clown. A smiley face.
A smiley face.
Nice.
So right now, if I had these coordinates that have already been specified here for you guys, what I'm going to end up with is going to be a big, lopsided smiley face. Like such.
Exactly.
And you can see how it's a perfect fit. 100% all the way. Now,
right, so basically from 0 to 1 in S and T, it specifies the entire range of your image.
Precisely. Now, I don't have to keep this 0 to 1.
No.
Now, that's just kind of like a default, let's make a perfect fit for a texture.
Right.
I could do something like, let's start from 0, 0, and now let's move over to, how about 0.5, 0. So no longer look at these numbers. Look at the new ones I'm drawing. So 0.5, 0. Up here, let's go ahead and cross that out. And what if I was to say go from 0.5 to 0.5, right? And then over here, let's say don't look at these. And bear with me, guys. I want to keep this from getting too cluttered. And then I said go to 0, 0.5. Here's what
so
you're going to have. So
we basically have to.
We have to. Let's not do that. Let's go ahead and there we go. Let's see. Down here, here's the best way to look at this. What I've done is I've taken this chunk right here. And if you guys don't mind real quick, what I'm going to do is we can go ahead and, well, we can just hide this out.
Yeah.
That'll work. Perfect. So now I can just come over here real quick and erase this out. I just want to not have to chop through to the layer underneath and show you guys some cool stuff. So we end up with something that looks like this.
Right, so we're looking at the bottom corner of the face.
Precisely. Now, if I would have done, just to show you guys, I can go above 1, 0. If I would have done this, 2, 0. So again, we're scratching this out. And then let's just, to make room, we're going to come up here. And if I would have gone to, let's say, 2, 2.
Yeah.
Yep. And
I
then,
see where you're going with this.
And then over here, bear with me for just a second. I'm almost there trying to keep things nice and clean. So we go to 0, 2. Now what I've done is really interesting. I've divided this guy up, but I'm going to show him over and over, and over, right?
Right.
So my one happy face down here is going to show up. In fact,
4
I
times.
should have just divided it here.
Yeah, that's okay.
So here we go. Smiley. But this does not have to be the case. Hang tight. I'm going to explain.
Okay.
Once we set up a texture in OpenGL, we have the ability to set all sorts of parameters.
That's
to
right.
do all filtering and to do if it's going to how the clamping is going to be.
Right. And that's
if it's going to repeat or not.
Mm-hmm.
Ooh, yeah. So in this particular case, you can notice I'm repeating.
Right.
Now,
So when it goes beyond the 0 to 1 range, what is it supposed to do? So you can basically tell OpenGL, well, I want it to repeat. In other words, it will tile your image multiple times to fill in that coordinate area that you specified.
You also can tell it not to repeat.
Mm-hmm.
And what's going to happen is in that particular case, you'll end up with this last row of pixels
getting smeared
just
all the
being
way across.
Smeared. This one pixel filling out this entire region.
Right.
And then these pixels, minus the last one, smearing this way.
Right.
You could tell it just to take one and tile it in that particular direction.
Right.
If you don't mind me using the word tiling. And have the pixel smear in the other direction. So we have all of these different options at our fingertips.
Basically, we can set in S, do we want it to repeat or clamp? Or in T, do we want to repeat or clamp?
Precisely.
So basically, we have complete control over how OpenGL decides our texture is going to get, placed onto a particular surface.
Right. Now, I want to show one more thing, and then I will try to be quiet. And that is...
You won't succeed.
Probably not. That is now what happens once we start dealing with 3D.
3D.
Because you'll notice that our polygons are sharing vertices.
Mm-hmm.
And all of our vertices need to be assigned an S and T coordinate.
That's right.
Once we start applying texture.
Because basically, think about this. If you don't specify a coordinate system, OpenGL is not going to know exactly how to put your surface onto it.
That's right.
Again, it's a state machine. So if you specify one and forget to specify the next one, it's going to use the exact same coordinate that you specified for the last vertex. So you're going to basically you're only going to see one pixel of your texture.
Exactly. So while you're up here just talking, everybody's watching me draw. Okay, so check this out.
So nobody heard anything I said.
No, I'm sure that. Rewind, guys. What Joel said was very important, I think. Just kidding. All right, this vertex right here. Check this out. Even though I've assigned it an ST coordinate.
Right.
This is for this particular polygon that's getting drawn.
Exactly.
In regards to my draw code.
Mm-hmm.
Now, when I go to draw this guy over here, I need to assign this again for the way this polygon is going to be drawn out.
Right, because if you remember back in our 3D cube, we had we started drawing geoquads, right?
Mm-hmm.
So for every single surface, we specified 4 separate geovertex calls.
That's
and
right.
for the next face, we did the same thing.
That's right. So in this case here, this guy would come in being, guess what? 0, 0. And if I'd follow this one out to be 1, 0 and 1, 1, and that's a 1, I promise. And then over here, 1, 0, or 0, 1, excuse me.
You can do it.
Then what we end up with is
the entire circle.
The entire thing with just the guy's smiley face, while this side over here is still, of course, a tiled texture, if that's how we set it up to draw.
Exactly.
So you can see how we can have different S and T coordinates on each different polygon face.
Exactly.
And just let OpenGL worry about the interpolation between one point to the next point.
Mm-hmm. It'll
do that for you nicely.
Right. And the one option you are given is how, as you mentioned before, how the filtering works.
That's right.
So you can set, do I want it to filter really nicely, depending on if it's really far away from the camera, really near to the camera, etc. So there's all sorts of parameters that you can set.
And we can set parameters up outside the main loop.
Mm-hmm.
We can set them up in the loop where they're set based on conditions that are looked for and met.
Exactly.
I mean, you're really
given a lot
open.
of freedom.
You sure are. Okay, so this is just a quick overview of how textures are laid onto polygonal surfaces.
Right, the S&T coordinate system.
Now, let's go ahead and start talking a little bit about, here we go, dun-dun-dun, next one. Textures. How do we work with OpenGL to make all of this happen?
What's the pipeline we need to do? And actually, it's really, really simple. Very,
it
very
really
simple.
is. You just need to get the base concept down.
Right.
And I'll see if I can do a crazy whiteboard example for you guys in a second. You'll notice we've got a few different functions up here. The very first thing is GL enable.
Right.
And you'll notice that we're passing it glTexture2D. This is very important. This is like a giant on-off switch. By default, our textures are disabled in OpenGL.
Right.
That's why we were able to see our cube with different colored faces.
Exactly.
I mean, we specified the colors, but we had never turned on textures. The moment you come in here and do a GL enable, what happens is you flip that light switch on, and at this point, we should have a texture. We must have a texture for every single polygon face that we draw in there.
Exactly.
Now, you can still use the color, right? We've got that just basically results in a tinting of your texture.
Right.
But if you don't apply a texture, then what's going to end up happening is, well, it's quite funny. You just get a blah kind of a grayish, whitish color thing, and you lose all 3D perspective. That's for sure. There's no shading or anything that lets you tell one side from the other.
Right, because we don't have lighting turned on yet.
Exactly. That'll come later.
Yes.
So anyways, the very first thing you're going to do is, of course, turn on GL enable. And obviously, this is not inside your main loop. This is outside your main loop.
Right. You want to, you can if you want
turn
to, like
say,
let's say I want this surface textured, I don't want this surface textured. You can interchange it if you want to. But typically, you would actually separate it into two passes or something like that.
Precisely. Now, and of course, the GL texture 2D, that could be 1D, 3D, whatever it is that you're about to enable.
Right.
Now, here we are, 4 different calls that lie at the heart of the entire texture system, if you will.
Right, kind of crucial if you're going to use textures.
Very crucial.
Yes.
We've got glGenTextures, glBindTexture, glTextImage, in this case 2D, because we're, again, in this VTM addressing 2D textures for the most part, and glTextParameterF. Now, how do these guys all work? Well, we could sit here and talk about it code-wise, or we could jump back over to the whiteboard real quick, and I'll draw you guys some more pictures.
Sweet.
Let's do some pictures. Whoa. Boy, that is pretty rough, isn't it?
Yes, it is.
So let's start over here by hiding that picture, and we'll go ahead and bring this guy back and activate this layer right here. And here we are. So glGenTextures, glBindTexture, and glTextImage 2D, and you'll notice the parameter 1 is missing. Don't worry about that. So what's going on? And of course, at this point, we are already assuming that GL enable has been activated.
Right.
So glGenTextures is looking for 2 things. First of all, how many textures are we about to use? So let's say that we are going to use 3 different textures. Okay. And then we need to
pass it a variable.
Pass it a variable in which it can turn around and populate with some ID information for us.
So in this case, we would say maybe a float with 3 elements.
So we'll just say that this is like
X or T.
Text.
Okay.
You like text, don't you?
Yes, I do.
So here's text down here, having a good old time.
It has 3 elements.
It has 3 elements. And what happens is OpenGL is responsible, because of the glGenTextures call, coming in here and giving us some ID numbers. So I'm just going to pick on 3, 4, and 5.
Basically, glGenTextures is going to return IDs that OpenGL still has available. Say we've already created 20 textures. We don't want to use the same IDs over again. So GenTextures will return to us 3 unique IDs that we can use for our textures.
That's right. Now, at this point, we're kind of working towards getting a texture associated with one of these IDs. At this point, all we've done is we've told OpenGL, all right, we've got some textures coming.
Right.
And we need to associate them with some numbers. Give us some numbers. And it says, okay, here's you some numbers. All right, thank you very much. Now what we need to do, is bind our textures to the particular texture. So check it out. What I'm doing is GL bind texture, and now I need to say to OpenGL, what kind of texture are we binding to? So we're going to say GL texture 2D, and now I'm going to bind it with one of these guys down here.
Let's say 5.
So let's say 5.
Okay. So basically at this point we're saying select a texture. We want to select texture number 5, which is the ID that OpenGL gave us. And then we need to start specifying what all is associated with this new texture. Because when you first say glGenTextures, you're given basically nothing.
Right.
You need to start populating it with image data. You need to set the parameters for the texture, et cetera, et cetera.
Exactly. Now, here's an interesting thing to think about. I tried to be as clear as possible, and Joel was as clear as possible in making you guys see how matrices work inside of OpenGL. And if you guys recall, we had the model view. So the model view, we had our projections, etc., right?
Right.
But at any given time, we can only set one, which means that when we go to modify, like by doing multiplication or something else, a matrix, it's going to modify only the one that's set. I mean, it can only modify the one that sets, because that's the whole idea of how OpenGL works, with it being a state machine. Well,
basically, we had to do a GL matrix mode, set the matrix we want to modify, and then all functions after that would use that particular matrix.
Precisely. Well, guess what? If you think about it, this image up here, doesn't that look kind of like this one down here?
Kind of, sort of.
We've got multiple textures, and look at this. I've got an arrow. Right now, we have set the one that we are working with.
Right, and that's the job of glBindTexture.
And that's the key thing here. So now that we've set it, now at this point, there's still no real texture, if you will. Okay, let's see. Let me get my mouse over here, pull that back down a little bit. All right, so now that we've got OpenGL pointing to the right one, this is who we're working with. Now, we've got some dots right here. Now we're going to go out and we're basically going to hit our own code.
Right.
And we're going to...
Or an external library.
I was about to say, or we're going to use an external library. Basically our own code that could utilize an external library or could directly load in an image.
Right.
Well, the bottom line is we're looking to open up an image and do whatever manipulation is required to get back the raw data.
Right, so basically, go to an external call that says load JPEG.
Right.
And it loads the JPEG from a file, uncompresses it and all that other stuff, and gives you back the raw RGB, RGBA data so that you have something to give back to OpenGL. Because OpenGL has no image loading capability.
Exactly.
All it has is things like, okay, I have a texture, you just give me the raw data in RGB format.
Exactly. So, interesting thing is that you can do all of this manually.
Yes,
every bit of the code. You can even do the decompression or uncompression yourself, if you'd like. We are going to, instead of using any free libraries out there, we are going to walk you through actually reading a header file from a simple TGA file and then pulling in the raw data based off the data in the header.
But in our case, it's simply going to be an uncompressed TGA.
That's right. So it's not that we're cheating. We're just taking the simplest approach because this is an introduction to OpenGL.
Right.
It's not how to manipulate advanced textures.
Yeah, how to decompress images. That's way beyond the scope of this VTM.
For sure. But the bottom line is if you use a free library or you handle it yourself, in the end, you're left with a chunk of memory that is containing the raw pixel data, RGB or RGBA, and other data.
Right, completely uncompressed.
That's uncompressed, that is required for the makeup of that texture.
Exactly.
So we send that back. Now, here comes the big thing. The glTexture 2D, this guy right here. This is where we are now making this association between raw data and Mr. Number 5 over there.
Right.
So at this point, this graphic that just came in, which just happened to be that smiley face, that is now known as ID number 5. And not only that, here's another thing that's interesting that we get out of the glText image, is that that's memory.
Right.
This is our graphics card.
Nice.
So, and that's where you plug your monitor. So now our image has been loaded onto the graphics card, and that's really important because that's go ahead.
If you were to load it either from local memory or something like that, you could have a serious problem.
Yeah, you could. Well,
it could be slow.
Massive slowdowns.
Right. Basically, if it's available to place, it will put it in the fast access memory so that you can just directly get it as fast as possible.
So when using the GL, yeah, thank you very much. Oh, I didn't want to undo that. There we go. So when using the glText image, when using this function call right here, basically we're going to specify several different things. We're going to tell OpenGL, okay, here's the width, here's the height, if you're going to use a border or not, here's the type, and then the last thing we're going to say is here's the pixels. And we're going to make this point to this right here. Now, we don't have to tell it which ID we're working with. We've already handled that right here.
Yep.
It knows this is who we're dealing with, and then when we do the text image 2D, it now makes that association between this guy and this guy.
Right, so every time we do a GLBind texture with 5, OpenGL knows to associate that with our smiley image.
That's right. And in a minute, when we jump back over to our PowerPoint show,
yes,
you guys will see that we're going to turn around next, and we can use the parameters F function where we can go in, and then we can start specifying various parameters. And again,
like our GLClamp, GLRepeat.
Exactly. And again, who is currently set.
Right.
And so then we can just repeat the process for loading in all of our textures, where we can bind with, let's say, number 4. We go out, we grab our data, we bring our data back in, and then again, we run this command again, and then we're now pointing at this guy. So now we're populating him, or not populating him, but now we're now associating him with some other graphic. Okay?
Right, exactly.
Now, this is all taking place outside our loop. Because in the end, remember, it's kind of all about that loop.
Right, because basically, I mean, think about it. Do you want to re-access your JPEG every single time during your loop?
Uncompress it every single time?
No.
No. But in our loop, this is pretty important.
Yes, it is.
Our GLBind. So if you guys don't mind, instead of typing out writing out all of GLBind, I'm just going to call it BND.
Okay.
All right, so this is our GLBind, and I'm going to say it's going to be 2D and number 4. So we now know that or let's just do 5, because that's going to be our smiley face. So we now know that we've got number 5 is the one that we're pointing at. So we've got our happy face is the one we're looking at. Then I can say draw a face, and that face is drawn with it. Draw another face, and that face is drawn with it.
Not forgetting to specify GL text coordinates.
Of course, that's a given.
Right.
So we go through and we draw all of these different faces, and they all continue to draw with the texture that we are currently bound to.
Our smiley face.
Our smiley face. And then if I need to switch over to something else, I could then simply say, all right, so now let's go ahead and do a GLBind texture and 2D, and this time we're going to use texture number 4. And
Let's say it's a wood texture or something.
And it's if it was a wood texture, check it out. Then we could say perhaps it was in 3D space, and over here was 6.
Right.
We had that loaded, and then we could draw out our chopped block of wood that has the little rings in it, so they exist in 3D space. So you can see that and this is in the loop itself, so of course, as we redraw this over and over and over, we're looping through. Very important concept to understand, so you can see how we're switching between all of our textures in our main loop.
Right. With one simple call, we can basically switch between, one texture or another.
Precisely. Okay, I'm done scribbling.
All right. So let's go back over into our PowerPoint. So these are
here
the
it is. Yeah, you guys can see it's really laid out pretty simple. The glGenTextures just takes in GL size I, send it in, and GL unsigned int basically give
a pointer to our textures.
Pointer to our textures.
Exactly.
Which it's going to turn around and populate with our IDs.
And then we bind it, bind our texture so that OpenGL knows which texture we want to modify.
And the target again, 2D, 3D, what kind of GL texture type, and then the texture itself, what number, 4 or 5 basically. And again, we're generalizing all of this.
Right.
Then we come down to GL text image, and this is where we're now going to associate. As a matter of fact, if you look at the bottom, the last parameter that we're passing GL text image 2D,
it's a pointer to our pixels.
It's a pointer to the pixels. So when I said here's a chunk of memory that contains all of our raw data, so now we're just passing over the pointer that's pointing to that.
Right, and just as a side note, I mean, it says GL void. The reason for that is because at first, text image doesn't know exactly what kind of data type we're supposed to expect. Should it be an unsigned char bunch of pointers, or is it just, an int or something like that? It needs to know exactly what type it is, and that's why you can specify the type as well. Precisely.
And then, of course, we now move down to the GL text parameter F command, where we can have multiple ones, because you can see how it's laid out. Basically, we send it a target, which, again, GL texture 2D, it's kind of weird, because it knows what we're working with on so many different levels.
Right.
But we specify it yet again. And then we give it the parameter name, and there's a whole bunch of parameters that already exist. So you give it one of those names, and you give it the parameter value that you wish to set the parameter to.
Right.
And then you could have another GL text parameter F and set the next parameter, and then the next parameter.
Right, and it's going to modify the texture that's currently being bound.
That's right, the one that GLBind texture has got us hooked up with.
Exactly.
Wow.
So that's that.
That's that. Now, let's go ahead and cruise on over to our next slide. There are a few texture utilities out there.
And our good old OpenGL utilities library.
And as we've already said a couple of times, these utility function calls are there to make life easier for you.
That's right.
There's a couple of really cool ones we thought we'd point out. Now, there's obviously quite a few.
Yep.
And the idea of this video is not to get into every single thing, but just to get you up and running. But we thought these were worth mentioning. You do have GLU build 2D bitmaps.
Right.
And this is awesome because what it's going to do is it's going to take your texture.
All right, let's say you have a 1024 by 1024 image.
And it's going to generate multiple textures that can basically be shown on the face, different ones depending on how far or how close we are to that particular face.
Right.
So we could end up with, we start out with 1024 by 1024.
So we build a 512 by
512, 256, 256, 128, 128,
etc.
64, and 32,
right.
all the way down. And then, you know, if we're so far away that it's basically showing a dot, do you really want it to have to deal with a 1024 by 1024, a 1 meg texture size?
No.
I mean, no.
No, there's no point.
So exactly. So this is really cool.
Yeah, this is one way you could do it. A lot of times people will generate in a texture file, and the texture will actually include every single version. So when you load your file, you automatically have all of them with
right.
you.
And then another one that we thought would be really handy to point out, though you should not need this.
Right.
That is, you should always work with textures that are powers of 2. 256 by 256.
Well, you have to. When you're inside of OpenGL.
Okay, you have to. Well, I say that you should because you can use GLU scale image to basically convert your image so that it is a power of 2 and that you can then use it. That's why I said you should always.
Right.
You guys should never need this command because it should always be an image that's a power of 2.
Right. When you create it in Photoshop or whatever, purposefully create a file that's a power of 2.
Why would you want to do something that's like 58 by 64?
Exactly. There's not really a point. I mean, the only real area where I can see this being used is if you're creating a 3D application and you have the user specify, you know, a particular texture that could be not a power of 2.
Exactly.
And at that point, you could use something like this.
Precisely. Now, so it's out there. So let's go ahead and move on. One more slide, guys. Now, we are going to show you in the next video, Joel's going to whip together a nice little texture class for you that's going to handle bringing in a simple TGA, completely manual, if you will. There are open source image libraries out there, and we've added 2 of them here, the Magic ++ and Free Image.
Right. Go check them out if you want to.
Feel free to head on over. These different guys, these guys support all sorts of file formats. I mean, like one of them supports 80 some odd different formats. It's just crazy.
Search around if you really want to support that many. Typically, what I would recommend in your own applications, let's say you're making a game engine. If you just want to support TGA files or just TIFF files or whatever, just find one set of functions or a class that supports just TGA.
Absolutely.
And just work with that. But if you do need a full-featured image library, like Free Image, go ahead and download that, check it out. And
they are free, which is awesome.
Free. Open source.
And open source, so you can get in there and see exactly how they're doing things, which is awesome as well. So we thought we'd bring this to your attention, but again, in this VTM, what we're going to do is we're going to handle everything at the low level. We're going to do it ourselves so that you guys get a good feel for how to go about doing something.
And in the OpenGL loader and particle engine, we'll be using the class that we created.
That's right. How cool is that? So that's pretty much everything I wanted to
I think mention. That's it.
All right. So with that, that's going to wrap up this video, and we can now move into the one where we put together the texture class we were talking about.
Awesome.
Thanks a lot, guys.